I'm Mikhail Ilin from Evolution. I'm work there as a JavaScript engineer, and I have some experience. And yes, I remember how to use Dreamweaver and Floats. I believe nobody knows how astonishing browser games can be, and how many advantages it has. And engineers at Evolution are focused on creating the most accessible and immersive experience for our players by using web technologies. So today I will show you why I think it is underestimated and what cool things you can do in browser. But let me first share something more personal. My first experience with 3D video games happened when I was 8 years old. I was lucky to be invited to use my father's workplace to play Doom for the first time in my life. This cover art exactly express my feelings and what I've seen sitting in front of CRT display with sound blaster and stereo speakers maxed out. I will never forget this feeling. Yes, I was really scared. I have never experienced anything like that before. And of course, now it looks very simple, but at that time, that was quite insane. My second overwhelming experience happened to me when the first Oculus VR headset was released like 20 years ago. Actually, it was an early adopter's developer kit. It had a lot of gear needs to be installed. The screen resolution was very low, and there were no any controllers and only 3 degrees of freedom. But there were already plenty of games and demos which bring me the idea that the future is here. This is one of example. You could really fly on the dragon or maybe ride on the roller coaster, and yes, it felt absolutely real. You may be surprised if I tell you that the next time I was astounded was when I joined Evolution 2 years ago. At that time, I already had many years of web development experience behind. I worked with React.js, I had experience with video streaming and 3D graphics, but I couldn't imagine how far people can go in their passion for engineering stuff and how powerful modern browsers are. In Evolution, we have a tradition that every new engineer has to pass a 2 weeks onboarding process. And the most interesting part of this process is that you must play all the games we have. Literally, we reserve several days for only playing all these games. That's just a part of it. And I believe this is a great way for newcomers to impress them and to motivate them. And here is what I learned during that time. Let's take a look at this variation of classic casino game. We call it lightning roulette. So when I first seen it, I was like, what is this thing? Is it a TV show, a video game, a Twitch stream? What's happening here? It's a bit complicated. So there is a live video stream from one of our studios where we can see the game presenter and the roulette wheel and the big screen and many other physical props. And on top of this video, there is this beautiful user interface. So it has a betting grid, same as you can see on the real roulette table, some UI elements like settings, balance, help section, and by the way, there is a chat feature. So let's think about what's happening here. Player can place bets on UI on the web application or send messages to chat. It goes, yeah, this is one. And it goes to server, which, yeah, and to the server, we send also this video stream from our cameras. And actually, there are several cameras in this studio, so these view angles are switching during the stream. The game presenter can interact with players by using the dealer UI. So it's hidden behind the camera. There is a dedicated computer with a screen. And at the background, there is a screen with multipliers, which are generated in real time. So you can see this beautiful lightning with number. This is a real screen with separate video stream, which is kind of generated with Unreal Engine. The ball is spinning automatically and it's pushed to the wheel every round and the results, and when the ball stops in the pocket, the result is being scanned and sent to the server as well, and all this data we send to UI, and we congratulate the players, and it's happening over and over again 24/7, and it's perfectly synchronized in time and space. Yeah, this this was for me really impressive. And actually, it works perfectly on any mobile device. So this is really amazing. And this is just a React application with some canvas animations. Of course, there is the video. And yeah, there are a lot of mechanical and electrical engineering behind this scene and a lot of people working on this video stream. We start thinking then, after making this game, what can we do to provide more immersive experience? Maybe we can make a video game. So we made a 3D version of the Lightning Roulette. So you don't need a studio, you don't need a game presenter, and it still feels quite realistic. We call such games the first person. Maybe to pay tribute to the first person shooters like Doom. Now it's a 3D scene with a roulette table. You can place bets like in real life by placing chips or dragging it around, and the ball is spinning and falling exactly on specific pocket, and the outcome is generated randomly on the server side. I was really impressed by the amount of details here. The shadows, the materials, textures, reflections on the floor, and how smooth animations are. And yeah, we are still in the web browser, even on mobile device. And yeah, it works perfectly smooth. It's also made with React. There are some 2D canvas animations, and for this 3D scene, of course, we use WebGL, and we use a lot this Babylon.js library. You may have noticed that lightning strike animation uh, here, I guess. So one of the first implementations was made using animated sprite image. So this is the example of such sprite sheet. Yes, the good old sprite animation, which was widely used in old games, and yeah, you could see this in Doom as well. So game artists were generating all these frames and sent us a quite big PNG image, and unfortunately, such images are quite big to use on the web. It really affected the loading time, and we definitely needed something different. So we start thinking what lightning is. Uh, a sequence of branches coming one from another. Maybe it may look like a tree, but yeah, a quite sophisticated randomized tree algorithm. So there is one nuance. So we need this lightning to follow particular shapes to draw these lightning animations between several points. So we started to think again, what can we do with that? It's not just a tree, of course. Yeah. So if we draw a simple line in 3D space. This is quite simple. Then we need to find some points in between and change and use these points as new coordinates for the same kind of lines. And we maybe then change the directions, add more and more lines, so make it recursively. And after several attempts, we've got a pretty customizable lightning strike generator. So it costs just a few kilobytes of code. No need to ask for game artists the new images, no need to download the images. You can be any shape, any size, and any color you like. And yes, it's the magic of software development. We reduce the game size, we reduce the amount of work, and yet a lot of flexibility we have. Speaking about magic, one thing caught my attention because I couldn't explain how is it made. So these smoky clouds on this bottom and these stars flying animation, what is that? Maybe you already can guess. So it's definitely not a GIF animation, but it could be. It could be a video recording, maybe. It is possible actually to use the videos and GIF in WebGL scene. Maybe it's a canvas or CSS animation, but of course no, because it's a 3D scene. There is no canvas inside the canvas, and there is no CSS in WebGL. It is a shader, and the shader appeared to be a big part of WebGL specification. So if you confused as I was, shader is a computer program which calculates the levels of light, darkness, and color while rendering the 3D scene. So long story short, it's a procedural graphics generation language called JLSL, which is widely used in 3D graphics. It renders purely on the GPU, and it is really efficient because it works kinda in a separate thread. So all these beautiful effects are just 1 kilobyte of code. Actually, in theory, it is possible to generate any object or scene by using just shaders. It will just take a lot of time to program and to make all these calculations, but you won't need any models or textures for that, only pure GLSL code. And this is an example of such animated shader, and this is the code. So the magical mystery 500 characters. Don't ask me what's happening here. It's all I can tell. It's a lot of math, a lot of calculations made, but you can observe it by yourself. You can check it on your phone, on the browser. And yeah, I recommend to check the shaders of the day on this website, Shader Toy. They are insane. People even generate the sound with shaders, and they generate the data for the sound and pass it to web audio API. So it's also really magic for me. But yeah, this sound case is more like proof of concept. You actually don't have to use it in real life in production. So people usually think that this is reserved for real games, but it works on the WebGL in any browser. Okay, let's check out another game. There is one thing I want to show. So Craps is a dice game which when players place bets on the outcome of the roll of a pair of dice. So this is a 3D scene, by the way, and for starting the game, we could make just a simple spin button like you've seen in previous case, but beside that, our engineers implemented a physics simulation of throwing the dice. like in Angry Birds, but in 3D space. This is a kind of feature of Babylon.js framework, but actually it relies on many physics simulation libraries that you can choose. And there are many ways to use it. For example, here you can see the explosion animation, and it follows by the hurricane effect. So yeah, you can check as well how it works on your mobiles or whatever. And yeah, in our case, that outcome is still randomly generated by the server, but the collision animation, it made me feel it is real. Okay, the next one, yeah, we have physics in browser, in WebGL, and so on. The next one was really surprising for me. On this screen, we have a slot machine with barely visible video on the background behind this curtain. And if you long enough gaze into the curtain may start gazing at you. And you may notice that these coins are rotating randomly, just a little bit. And some of the coins has this shiny glares animation. And every time you load the page, the position is random. So it always randomly generated. And it's kind of can be infinite long and it is responsive. So, how is it made? Of course, the first thing that we think is maybe a GIF animation. Of course, it will be a low quality. There is no decent transparency channels, and yes, extra HTTP request will need it, and a lot of kilobytes to download. Maybe we can use some PNG images and generate a grid with JavaScript and animate it with CSS. But it seems to me our engineers will still be unhappy with that solution. You have to generate hundreds of HTML elements and somehow randomize its animation start time. Otherwise, it all will look quite synchronized and fake. And of course, this is much less performant than the approach our engineers suggested. So luckily, we have some smart guys. So they made it with WebGL and shaders. And there is only one tiny image sprite used. It's about 10 kilobytes. So we had that slot machine already made with tiny 3D library called OGL, and we use it a library for curtain animation as well. But the lines itself, the coins rotations, the sparkle animations, so the way how we transform this coin position, it is made using shaders. As a result, it is lightweight, it is really customizable, it is responsive, and the most advantage of this, it is performant. It is made with Pure.js and GLSL. It is rendered and animated with GPU. So we remember that CPU is quite expensive to use. So if you have a WebGL support, this approach should work. All right, the last stop in our journey is the Gonzo Treasure Hunt live show. At first glance, it seemed like nothing special here, like we already know most of the components involved, but just a quick recap. There is a video stream from our studio, the 3D graphics on the background, and this guy with beard staying to the left. He is also generated with Unreal Engine. There is a player UI, there is a dealer UI behind the cameras. But there is a tiny button added at the top of the screen. It turns out this game also playable in VR mode. So this is absolutely different video stream, and we have these two cameras positioned in the studio to make a 3D effect, and this character walks around you, and this video for VR is kind of this 3D spherical shape, so you can look around anytime, and you can click anywhere, you can use your controllers, you can look around, everything you would expect to do in VR. But there was one problem. In 3D world, there are no HTML elements at all. So no React JSX and no CSS. For that reason, the whole user interface which you see was recreated with 3D graphics. So all buttons, all sliders, all inputs, all of that are 3D objects. And you can use them, you can click on them with your controllers, you can scroll and swipe, do whatever you like. That was quite challenging, but we did it. So what a combination we've got in the end. Interactive 3D spherical video, 2D canvas UI, React application, uh, screen or studio props from the studio, the WebGL, the 3D graphics, the shaders are widely used there. We can use physics, and of course, we can use the virtual reality in any browser, on any device, of course. So, for a long time, I thought that there is a world of serious game development where people do really cool 3D games for consoles or high-end PCs. The world of 3D optimizations, GPU shader computations, shadows and reflections, realistic physics, and virtual reality. But it all appears to be available to any JavaScript engineer. And there are many tools and libraries available right now. So, for example, this Babylon.js library ecosystem has its playground like JS Fiddle or CodePen, but for 3D graphics and work with Babylon.js. So you can experiment and code straight away in browser. There are powerful developer tools where you can navigate the scene, you can check your meshes, its position, its materials and textures. There is a performance analysis tool, so you can debug the performance as well. There is a quite new UI editor, so you can generate UI in this editor and then use in your game. And there is an animation editor. You can edit the curves, the timings, and so on. And there is a material editor. So a lot of stuff made or for making 3D graphics in browser really easy. It's really easy to share with others as well. And yes, your players don't have to install or download any software or buy any specific device to play it. So feels like the future is here. You can trust me. At Evolution, we build world famous games just by using the web browser. Any questions? Okay, is it not terribly expensive to acquire users for such games? I Can I tell you about users? Of course, there is a high bar for hiring or teaching developers. But about users, I guess it's not a big deal because it's all accessible. So it works in the browser, it works in mobile device. You don't have to install applications. You can play the game straight away. Interesting question. I wish I knew all these business details about the amount of players we have. I believe personally, I think uh, we had some raise in number of players during pandemic because of course uh, everything goes online and people spend more time sitting on their computers as well. You plan to make yourself and make bigger games? The question. Mhm. I do some experiments, and of course, sometimes I dream of having my personal project. Uh, it takes time. Yeah, I guess one day I'll be there. What does the financial packaging look like? How much does such a game cost? It's really hard for me to calculate, and even I'm not sure if I could. I'm not sure if I could share all this information. So, in average, it takes from 6 to 12 months to create a new game, like this latest one, Gonzo with VR. But I feel that every new game is kind of easier to develop because we accumulate this engineering experience, and yeah, I guess it's become easier every year. Thanks for the presentation. What sources of learning? I guess you can start. Okay, for me, as I really experienced with Babylon JS, for me, this is the starting point. So the Babylon JS has a good documentation, has this playground services, a lot of stuff. It's the entry level is quite high. The bar is quite hard, so it's not so really easy. There are a lot of questions you have to learn, but the documentation is good. And yeah, as well, you can try the 3JS. The community in 3JS is quite bigger than Babylon. But yeah, there are some differences in these libraries, different tools, different API, but both of these are really good to start. And of course, YouTube. There are a lot of tutorials on YouTube. Any more questions? No more questions. Then thank you for your time. Thank you for joining. I hope to see you again someday. And yeah, the recording would be available on YouTube and on Facebook. See ya.